this is the last one we're going to cover because there are several other sections here. One of them is talking about transformations and other parts that we can do with these, but this is as far as we're going to take it. I mean, there are some optimization type problems with this that we could do in solving for different things. We most likely are not. We'll finish it on Monday, but what's left of what we have of this after today is not going to be a whole lot. Now, all right, guys, we're going to go on and get started. Now, the first thing we're looking at is the fundamental theorem of algebra. Fundamental theorem of algebra. And the fundamental theorem of algebra states if f of x is a polynomial of degree n, where n is greater than 0, then the equation f of x equals 0 has at least one solution in the set of complex numbers. One solution is going to be a part of the complex numbers. Well, we could say that x is equal to 1, yes? Is this a complex number? Well, no, it's just 1, right? There, it's a complex number. I mean, realistically, that's it. We can make any number a complex number in the form of a plus bi. So there is at least one solution in the complex plane. Now, that doesn't mean a whole lot for us. The corollary is actually a little more important. Well, not more important. We like it a little better. And it states if f of x is a polynomial of degree n, where n is greater than 0, then f of x equals 0 has exactly n solutions, provided each solution repeated twice is counted as 2 solutions, and each solution repeated 3 times is counted as 3 solutions, and so on and so forth. Well, n is our degree, yes? Thus, thank you. It does indeed. So I leave it slightly cracked because we do have one coming back. So, looking at this one here, how many solutions does this have? 3, because the degree is 3. So the number of solutions is 3. Now, we're not finding them at this point, but if we did, the solutions would be -3, 4i, and -4i. Next one. How many zeros does this function have?
1. No.
So what's the degree?
4. Yeah, it has 1.
So the number of zeros is 4. Because when we call it a 0, we're trying to find out what value of x will make the function equal 0. Well, that's the same thing as solutions. So we have this here. Incidentally, the solutions or the zeros for this here are -2, -2, -2, and 0. So we have 3 -2's and zeros, but we do have a total of 4 solutions. How many solutions does this equation have? 4. How many zeros does this one have? 3. Yes. Now we need to find them. So the number of zeros that this one has is indeed 5. Now there's several methods that we can go about for finding these. The first one, in the way that the book talks about this here, is we use the rational zeros theorem, or plus or minus p over q. We list out all the rational zeros, and then we try certain rational zeros to see if we get a remainder of 0. If we do, then it's a solution and we can move on from there. But rational zeros, or as we've been doing the other day with graphing, either way, we need to find at least 3. Because if we can find 3 solutions for this here, we can take it from a degree 5 down to a degree 2. Because for each solution we have that we remove from the equation, we decrease the degree. which means we have less solutions to find, less solutions that we don't know what they are. And the rational zeros is helpful in doing this by decreasing the degree. Now, the other way is just to graph this. So I'm going to clear that out. So we'll type the equation in, x to the fifth plus x cubed minus 2x squared minus 12x minus 8. And once we get it typed in, we're going to hit graph. Let me get this here. We all get the same graph? Or something that looks like this here, yes? Now we do see that it intersects the x-axis at 2 points. One of those 2 points it crosses, and the other it just touches the x-axis and goes back down. Now, the algebra book that we have really doesn't talk about multiplicity, but whenever it intersects the x-axis but doesn't cross it, it has an even multiplicity. So the number of zeros at that point are repeated an even number of times. If it crosses, they repeat an odd number of times. Now, we don't talk too much about that in one way or the other, because it means at 2, the number of solutions there is an odd number, which for the most part, it means it repeats once. And for our other point, -1, there's a good chance it repeats twice. Now, for sure, we know that x is equal to 2 and x is equal to -1. We have these 2 zeros. And what we can do from here, synthetic division, we can start off with 2. Numbers going across the top would be 1 for x to the fifth. Since we don't have an x to the fourth, it would be filled in as 0. 1 for x cubed, -2 for x squared, -12 for x, and -8 is our constant term. And we bring down the 1. Questions on this here before we get started? Now the next thing we can do is our multiplication. 2 times 1 is 2. 0 plus 2 is 2. 2 times 2 is 4. 1 plus 4 is 5. 2 times 5 is 10. -2 plus 10 is +8. 2 times 8 is 16. -12 plus 16 is 4. And lastly, 2 times 4 is 8. And our -8 plus 8 is 0. Now that is the remainder we wanted. We needed to get, because again, it told us it was a solution already. So we knew the remainder should be 0. Questions on this here? Now the other solution they gave us was -1. Bring down the 1. -1 times 1 is -1. 2 plus -1 is 1. -1 times 1 is -1. 5 plus -1 is 4. -1 times 4 is -4. 8 plus -4 is 4. -1 times 4 is -4, giving us 0. Questions on how we got to this point here? Now it is possible to factor this cubic, but instead of that, we're going to use the fact that we noticed on the graph at -1, it looks like it touched the x-axis but didn't cross it. So there's a good chance there's an even number of zeros there. So what we can do is we can try -1 again. -1 times 1 is -1. 1 plus negative 1 is 0. Negative 1 times 0 is 4 plus 0 is negative 1 times 4 is, and 4 plus negative 4 is 0. And that's it for that one there. Now, we could try this again with, say, 1. I can try these solutions again, see if they work. 1 times 1 is, well, not 1, it'd be negative 1. Negative 1 times 1 is negative 1. 0 plus negative 1 is negative 1. Negative 1 times negative 1 is 1. And 4 plus 1 gives us 5. So negative 1 does not work a third time. But also, if it worked a third time, because most likely there's an even multiplicity, it would have to actually work a fourth time. It would have to work 2 more times. It does not. The other one we could try is 2. 2 times 1 is 2. 0 plus 2 is 2. 2 times 2 is 4. And 4 plus 4 is 8. It's very tempting, especially looking at the last one. Maybe negative 2 could have worked, because then it looks like we'd have 4 minus 4. But if we tried negative 2, 1 times negative 2 would be negative 2. 0 plus negative 2 is negative 2 times negative 2 is 4. 4 plus 4 is 8. Also, on the graph, did it cross at negative 2? No, so it wasn't the solution to begin with. So what we're left is this here. And what we can do is put our variables back in. 4 is our constant term, our term without a variable. 0 is our term with x, and 1 is our term with x squared. So what we're left with is x squared plus 4 is equal to 0. This one is kind of nice, because this quadratic does not have a middle term. And if it doesn't have a middle term, we can use the square root method. We can get the x squared term by itself. And to do that, we would subtract 4 from both sides, telling us x squared is equal to negative 4. Square root both sides. Exactly, well, almost. Yes and yes. Because the square root of x squared is x. Anytime we take the square root of both sides, we have to add the plus and negative, plus and minus. And square root of 4, negative 4. Exactly. So the negative would come out as I. Square root of 4 is 2. So our last two answers are positive and negative 2i. So if we listed out all the solutions, and I'll put these back up here with the rest, we had that x was negative 1 twice, and x is equal to plus or minus 2i. Questions on any of this here? Now, even in odd multiplicity with answers, touching the graph and crossing it is kind of helpful, especially for solving these higher degree polynomial functions. Now, I didn't do this in the other hours, but I do think it would be interesting for y'all to see this, is this one here. Because how many times does negative 2 show up as a solution? Odd. Thus, by this understanding of the functions, x to the fourth, 6, 12, 8. All positive. 6. Thank you. 12. 8. At 2, or at negative 2, we see that it does cross the x-axis. and the other one, it crosses it well. Well, at -2, we have 3. We have an odd number of solutions. At 0, we have 1, an odd number of solutions, so it will cross. If it's an even amount, it's not going to cross the x-axis. But in any case with any of these here, we're still trying to find the number of zeros so that we get the degree down to at least, or at most, a degree 2, a quadratic. So here, x cubed plus 7x squared plus 16x plus 12. I would graph it. X cubed plus 6x squared. I lost the third term. Plus 12. And that should be a 7. Plus 7x squared. Yeah. X cubed plus 7x squared plus 16x plus 12. This is why I normally try to hold on to a note sheet. And hit graph, see what we get. If we look at the table, -3 and -2 are two x values. They give us a y value of 0. So for us to get it down to a quadratic, we needed 1. This time it gave us 2. That's even better. It's not the best, because the best would have been all 3. Because if it gave us all 3, we are done already. A degree 1, a linear. So we'd have an x term and a constant. And there's a good chance the graph already gave us what the other term is. So we'll do synthetic division. -3 times 1 is 7 plus -3 is 4. -3 times 4 is -12. 16 plus -12 is 4. -3 times 4 is now we can do it again with -2. -2 times 1 is -2. 4 plus -2 is -2 times 2 is, which gives us 0. At this point here, we can plug the variables back in. Remainder 2 is our term without x. So this is telling us that x plus 2 is 0. Solve for the value of x. So it technically did give us all 3. It was just kind of hard to see that -2 was repeated. Questions on this here? Now before I go after, or before, when I solve these here, and I'm looking at the solutions, I will say before I start trying to find repeated solutions, I try to exhaust all the solutions that were given to me. So like here, I tried -3 and then -2. I could solve for the rest. The previous one where we had the degree 5, it gave me 2, -1, and 2. I did -2, I did -1. Didn't get far enough down to where I could just solve the quadratic. So then I started looking for repeated solutions to see if there were any. Because when we graphed it, it looked like there could be. Then I started hunting for them. Let's look at this one here. Y equals x to the 5th minus 3x to the 4th plus 5x to the 3rd minus x squared minus 6x plus 4. Got our plane shape. Now we do have 2 zeros at least, yes? Same graph. -1 and 1. Most likely, yes. If not both of them. We can do 1 first. Now, picking which one you want to do first, that is completely up to y'all. Because I just pick one that I think will work out nicely, or at least decrease the numbers a little quicker than the others to kind of make things a little simpler. If 0 is a solution, go on and do it first. Because each time we multiply, we're multiplying with 0. Anything times 0 is 0. So it does simplify things a little bit quicker. Now here, our 1 times 1 is 1. -3 plus 1 is -2. 1 times -2 is -2. 5 plus -2 is 3. 1 times 3 is 3. -1 plus 3 is 2. 1 times 2 is 2. -6 plus 2 is -4. And 1 times -4 is -4, and -4 plus 4 is 0. Questions on this here before we move on to -1? Now, if we do the multiplication of -1, -1 times 1 is -1. -2 plus -1 is -3. -1 times -3 is 3 plus 3 is 6. -1 times 6 is -6. -4. So 2 plus -6 is -4. -1 times -4 is 4. 0. Questions on this here? Now, I do want to show you this because this is a little side note. Doing these in the calculator, I'm going to borrow. What I do a lot of times is use the A and S feature, and this goes pretty quickly.
Brandon Fowler, please come to the office. Brandon Fowler, please come to the office.
So, in the last one, our first one was 1 times -1, yes? And we got that there. We put it under the -2, and so we added -2 to it, yes? Then we multiplied it by -1. The 3 went under the 3, yes? So if we add it to 3, 6 below the line, then we multiply it by -1. And we add it to our 2, multiply by -1, and then we added it to -4. Y'all see how that works? So that is a way that you can do these in a calculator that is a little bit quicker, or you can do it one at a time and type them in. Either way works. This saves a little bit of time, but not a whole lot. All right. Well, we said which one was possibly repeated. -1, so we can do this again. -1 times 1 is -1. -3 plus -1 is -1 times -4 is 6 plus 4 is 10. -1 times 10 is -10, -14. So that's not it. So let's try 1. One times 1 is -3 plus 1 is 1 times -2 is 6 plus -2 is 1 times 4 is, and -4 plus 4 is 0. So we get to this point here. Interestingly enough, if it doesn't work at any point along the way, it's not going to work again. because what we're doing with this synthetic division is removing solutions from the solution set. Now, if you think of it as a bag of, in this case, 5 objects, we're trying to guess which one it is. And each time we guess right, we remove one of the objects from the bag. So if -1 appears only twice, we removed both of those from the bag, we know that the remaining ones can't be it. So if at any point we guess and pull out something that's not there, or it's told not in the bag, we know it can't show up again. Which is helpful to know, because if it fails on the first one, we know we don't have to try it again on any of the preceding ones because it's not there. If it's not there to begin with, it can't just magically show up later, unlike subatomic particles. So now here, we're going to fill our variables back in. 4 is our constant term. 2 is our term with x. 1 is our term with x squared. Now, I did give you all a way to check to see if something is factorable. Our square root of b squared minus 4ac. Well, I didn't really give it to you. That's half the quadratic equation. Here, we can say second square root. Our value b is -2 squared minus 4 times 1 times 4, because a was 1, c was 4, and b is -2. Enter. Domain error. So it's not factorable, and what that's also telling us is that whatever's inside the radical is a negative, because these calculators, 30xs, cannot take the square root of a negative, which also means I is probably going to be part of our answer. Almost. So here, a is 1, b is -2, and c is 4. And if we look at this here, x squared minus 2x plus 4, there is not a number in common with all 3 terms, so we can't divide anything out. Now we're going to plug our variables values in. So -b would be -2. Square root of -2 squared minus 4 times a times c all over 2 times a. Questions on how we type this in? At this point here, -2 is +2. The denominator, 2 times 1 is 2. So in the calculator, I would use the 30xs because I find it sometimes easier to type our -2 squared minus 4 times 1 times 4 in. Works a little bit quicker. We get -12. So that does explain to us why, when we tried to take the square root of b squared minus 4ac earlier, we got an error. Because the 30xs cannot take the square root of a negative. Yes. Now, to help us and help the yellow calculator be able to simplify the square root of -12, we know the negative will always come out as I, leaving us with the square root of 12. Now, I can plug in the square root of 12. It's fine with that. 2 squared root of 3, which tells us the square root of -12 is 2i, square root of 3. Graphing calculator would be able to handle this. It would tell us it is 2i squared root of 3, but it would tell us the decimal approximation, not the simplified radical version. Now, at this point here, we do or can simplify this, because if we split the fraction up like we did yesterday, we have this kind of common factor of 2. Well, our 2 divided by 2 is 1, plus or minus Again, the 2 over 2 is 1 times our I squared of 3, or just I squared of 3, telling us that we have 1 plus or minus I squared of 3. Now, we only really do this if A, it's asking for all of our answers in standard form in this here, or B, the two numerators are both divisible by whatever the denominator is. Nicely, we try to reduce it. However, if, I'm going to change it just a little bit. Well, went too far up. Let's just say that this was 3. I'd have left it there, because 3 and 2i do not divide by 2 nicely. One of them does, the other doesn't. Might as well leave it there. Does that make sense? If both of the top ones are divisible by the bottom in any way, shape, or form, we reduce it to make it look a little nicer. Here, doesn't work that way. If it had been 3, so we'd have left it alone. But 1 plus or minus we get this here. Questions on this so far? Okay. Complex conjugate theorem. You can write this down, you don't have to. It's almost the same as our irrational conjugates theorem, in that if A plus BI is a solution, A minus BI is also. They come in pairs. If we have one, we have to have another. Does that make sense? And we're going to finish off the note sheets today, or not finish, we're going to finish the lesson today. We'll finish the note sheets on Monday with this here. This is the same thing we finished 4, 5 with. They told us the zeros, that x is equal to 2, and x is equal to 3 plus I, and because of our complex conjugates theorem, since 3 plus I is a solution, it means 3 minus I is also a solution. If we have one, we have to have the other. Now at this point here, we need to get each one of these equal to 0. So we can subtract 2, telling us x minus 2 is 0. Yes? The next one, first thing we would do is telling us x minus 3 I. Then we would subtract our I, telling us x minus 3. Questions on how we got these first two here? Questions on this so far? What's the only difference between the one we just got equal to 0 and the next one? It's a positive I instead of negative I, yes? The sign's flipped. Well, that means there's a good chance this is going to end up being x minus 3 plus I, because the only thing that changed was the sign in front of I. Now, saying that and showing it are kind of two different things. So we can minus 3, telling us x minus 3 is equal to negative I. Then we would add I to both sides to get us x minus 3 plus I. Questions on this here? Now we're going to multiply these three expressions together. And just like with the radicals, I would suggest multiplying the complex conjugates together first. It is possible to do this with our x minus 2 times our x minus 3 minus I, and then multiply the other one together. If I remember correctly, we get 18 terms before we start simplifying down. Now here, if we do our complex conjugates first, distribute the x times x is x squared. X times negative 3 is negative 3x. And x times I is plus xi. And we do the same with negative 3. Negative 3 times x is negative 3x. Negative 3 times negative 3 is plus 9. And negative 3 times I is negative 3i. And lastly, distributing the I times x is negative xi. I times negative 3, negative times a negative is a positive, 3i. And lastly, negative I times I is negative I squared. Questions on how we got to this here? Questions on any of this so far? Now the next thing we're going to do is some simplifying. I don't know about y'all. I don't like having to rewrite things more times than I absolutely have to. Yes? Now we know I, well, we'll get to that in a second, but if we look at the I terms, we have negative xi and positive xi, yes? What is xi minus xi? 0. They are gone. Our negative 3i plus 3i is 0. So they are gone. So our only I term left is our negative I squared, yes? Well, we know I deals with our square root of negative 1. And one of the ones I told you that was pretty helpful was knowing what I squared is, yes? And it is negative 1. So what we're saying here is that this I squared is negative negative 1, which is just plus 1, yes? So really, we can just say it is plus 1. And for me, for the most part, and I go over this in the trigonometry in pre-calculus and above, is that I squared is negative 1, so it's really just changing the sign in front of that term. So it had been 1i squared, negative 1i squared, now it's just plus 1. Now we can combine our other terms. We just have x squared, our negative 3x minus 3x is negative 6x. 9 plus 1 is plus 10. And lastly, we do this multiplication again. X times x squared is x cubed. X times negative 6x is negative 6x squared. X times 10 is plus 10x. And lastly, we're going to distribute the 2. Negative 2 times x squared is negative 2x squared. So negative 2 times x squared is negative 2x squared. Negative 2 times negative 6x is plus 12x. And negative 2 times 10 is negative 20. And when I said 18 terms, I meant at this point here. It would have been 18 if we did it the other way. Now at this point here, we can combine like terms. X cubed, negative 6x squared, minus 2x squared, negative 8x squared. 10x plus 12x is plus 22x, yes. I don't know why I just wrote 12x. 22x, and then minus 20. And that's it. Questions on this here? Monday, what we're going to start off with is one of these here. So we'll do one more of these here, and then go over Descartes' rule of signs. Rene Descartes. Most likely you've heard of him, but not realize you know of him. He's actually more famous for philosophy in some ways. I think, therefore I am, was actually came up with by Rene Descartes.